All right, so this is the key to the worksheet on lines, and basically in number 1 and number 2, you're given two lines, and the two lines you'll notice that are passing through a pair of points. And you want to determine if these two lines, the first line and the second line, are parallel, perpendicular, or neither. And you can do that for numbers 1 and 2, where you're given points on the line. Now remember, all you need for numbers 1 and 2 is the slope. So you know the slope formula, so that's what you had to use. That's all you had to use was the slope formula. Find the slope of the line, and then you could determine if the lines are parallel, perpendicular, or neither. Now number 3, to determine if those are parallel, perpendicular, or neither, notice that you're given equations of the line. And what you want to do in both cases is find the slope, just like you did in 1 and 2, except these are equations. And to determine the slope, you're going to use the idea of slope-intercept form. And so the slope of the, or the coefficient of the x-coordinate will be the slope once you find the slope-intercept form. So that's going to be the idea there. Okay, so let's look at number 1. So number 1, you're given line, I'll call this line 1, and you're given that line 1 contains these points right here. So the points are 7, 6, and 4, 3. And to find the slope, remember the slope formula is y2 minus y1 over x2 minus x1. And it helps to label these. So let's call this x1, y1, and this will be x2, y2. Now remember, the slope, you're going to put the y-coordinates on top in the numerator and the x-coordinates in the denominator. And the order matters how you do this. So if you put the second y-coordinate first, then you have to put the second x-coordinate in the denominator first. Okay, so, and that's why we label these. Sometimes it helps to do that. So we have 3 subtract y1, which is 6, divided by x2, which is 4, subtract x1, which is 7. And then 3 subtract 6 is a negative 3, 4 subtract 7 is a negative 3, and a negative 3 divided by negative 3 is a positive 1. All right, so that's the slope of line 1. Now in line 2, you have these points. So your points in line 2 are 4, negative 5, and 2, negative 7. And let's go ahead and label these x1, y1, x2, y2, and let's find the slope. So the slope, you're going to say y2, which is negative 7, subtract y1, which is negative 5, divided by x2, which is 2, subtract x1, which is 4. And so negative 5 subtract, negative 7 subtract negative 5, remember, means the same thing as saying negative 7 plus the opposite of a negative 5, so that means plus a positive 5. And then 2 subtract 4 means 2 plus the opposite of 4, which is a negative 4. And then using the idea of signed numbers, you have negative 7 plus 5, which is a negative 2, 2 plus a negative 4, which is negative 2. A negative 2 divided by negative 2 is a positive 1. Using your calculator, you could have done the same thing. So you would have said negative 7 subtract negative 5 equals negative 2. And then 2 subtract 4 equals negative 2. Notice, though, in both of these cases, the slopes are equal. All right, so then you're going to say this. You're going to say, since, now you have to show this work right here, and so you have to say, since the slopes are equal, okay, slopes are equal, the lines are parallel. You can't just say the lines are parallel. You can't just show me this and say the lines are parallel. You got to tell me why. Why are the lines parallel? The lines are parallel because the slope here is 1, the slope here is 1, and they're equal. Okay? All right, so that was number 1. Number 2, same idea. You're going to do the same process, except this time line 1 has these points on it, 5, negative 2, and 3, negative 7. And we're going to go ahead and label these just like we did before. And so the slope, you're going to say y2, which is negative 7, subtract y1, which is negative 2, divided by x2, which is 3, subtract x1, which is 5. And then negative 7 subtract negative 2 means negative 7 plus 2. 3 subtract negative 5 means 3 plus a negative 5. Negative 7 plus 2 is a negative 5. 3 plus a negative 5 is a negative 2. A negative divided by negative is a positive, so you need to rewrite this as 5/2. Okay? You could use your calculator with that as well. For line 2, we have these points, negative 3, 5, and the other one is 2, 3. So x1, y1, x2, y2. So the slope for line 2 will be 3 subtract 5, y2 minus y1, over x2, which is 2, subtract x1, which is negative 3. 3 subtract 5 is a negative 2. 2 subtract negative 3 is a positive 5, and you get negative 2/5. All right, so there's the slope of line 1. There's the slope of line 2. So you're going to say this. You're going to say since, so I see the slopes. You're giving me the slopes. Okay, so since the slopes are negative reciprocals of each other, the two lines are perpendicular. Okay, so the two lines would be perpendicular. All right, so that is number 2. All right, so for number 2, what I want to do is actually draw those lines, and just to kind of show you what perpendicular lines look like, or remind you what they look like. So my 2 points, so line 1 contains these 2 points, so 5, negative 2. So to plot the point 5, negative 2, I'm going to go from the origin, I'm going to go to the right 5, and then y is negative 2, so I'm going to go down 2. All right, so there's the point 5, negative 2. The other point is 3, negative 7. So 3, negative 7 right here. So there's the other point. So when I graph that line, when I graph this line, like this, so this is the line that goes through these 2 points, and you're told the slope is positive 5/2, meaning that since the slope is positive, the line has to rise, and it is. All right, so this is a slope. So this is a line whose slope is 5/2. The other line goes to the point negative 3, 5 and 2, 3. So when I plot that, negative 3, 5 is right here, and then 2, 3 is right here. So when I draw that line, it looks something like this. Okay? And notice that that line is falling as I go from left to right, so it's going to have a negative slope, and it does. It's negative 2/5. So that slope is negative 2/5. And what I just found was that these two lines that have slopes that are negative reciprocals of each other will intersect at right angles. So notice that these two lines look like they're intersecting at 90-degree angles. All right, so that's what you found in number 2. All right. Okay, so let's look at number 3. Now 3A, notice that these two lines here are already in slope-intercept form. So since they're in slope-intercept form, it'll make things a little bit easier for us. So let me go ahead and write this out. So 3A, this is 3A. You have y equals 3/5 x plus 2, and y equals negative 5/3 x minus 1. So remember, this is already in slope-intercept form. And so slope-intercept form, y equals mx plus b, where the coefficient of x is your slope. This is your slope, the coefficient of x. So the slope is m. So notice that in this case, for this line here, my slope is 3/5. Over here, my slope is -5/3. So you have to tell me what the slope was. You can't just say the lines are perpendicular. Why are they perpendicular? You got to tell me why. Well, you found the slope. So you found the slope of this line is 3/5. You found the slope of that line is -5/3, right? Okay, so now let's compare the slopes. Notice that in these two lines, those two numbers here are negative reciprocals of each other. So then you're going to say that. You're going to say since, but I had to see something about the slope. I had to see a number. So since the lines, since the slopes are negative reciprocals of each other, since the slopes are negative reciprocals of each other, the two lines are perpendicular. Okay, so the two lines are perpendicular. And you can see they're perpendicular. If you had a protractor, you could actually measure it if you draw this as best you can. But look, so here's that first line, right? So let's go ahead and graph the first line and see what it looks like. So remember, in slope-intercept form, the constant is your y-intercept. So my y-intercept is 2. So that first line that we just looked at is going to cross the y-axis at 2, and it has slope 3/5. So from this y-intercept, I'm going to go up 3. So remember, positive, positive. So rise over run. Okay, we've talked about that before, rise over run. So you can go up 3 and then to the right 5. 1, 2, 3, 1, 2, 3, 4, 5. All right, and so that point here is 0, 2. That's your y-intercept, and that point here is 5, 5. All right, and then when you draw that line, you have something that looks like this. So that's that first line. So that's the line y equals 3/5 x plus 2. The other line is y equals -5/3 x minus 1. So that -1 is your y-intercept there. So that's this right here. And then from your y-intercept, I'm going to use the slope. So the slope is -5/3. So I'm going to go down 5 because it's negative. 1, 2, 3, 4, 5. And then to the right 3. 1, 2, 3. So there's that other point right here. So that point we'll label 3, -6. And this point here was 0, -1. But when I draw that line, I want you to notice, since the slopes are negative reciprocals of each other, I want you to notice that they intersect, or they should intersect, at right angles. Okay? All right. So that was number 3A. All right, now let's look at 3B. So 3B, this time you have 3x minus 5y equals 7, and then 10x plus 6y equals 12. Now notice these equations are not in slope-intercept form, so you got to tell me what that slope is. I have to see what that slope is. So let's go ahead and transform those two equations in slope-intercept form. So we're going to get y by itself. All right, so what most students are going to do in that first one is they're going to go ahead and subtract 3x from both sides. And so when I combine like terms, I get 0 and -5y is a -5y equal, and let's put x first, so that's -3x plus 7. Then, let me go ahead and rewrite this over. So then what they're going to do is to get y by itself, they're going to divide both sides by -5, like this. And then we're going to get -5 divided by -5 is 1. 1 times y is y. So we get y equals this. Now I'm going to put this in the form mx plus b. So I'm going to write this as two fractions. So that's going to be -3x divided by -5 plus 7 divided by -5. And now let's go ahead and make this look better. So that's going to be negative divided by negative is a positive. So that'll be 3/5 x. A positive divided by negative is a negative, so minus 7/5. And remember, all you need is a slope. So the slope of that line is 3/5. So you found the slope. There's the work. You found the slope. Now let's get this one. So for this one, we'll go ahead and subtract 10x from both sides and do the same thing. So this is 0. We get 6y equal negative 10x plus 12. And then to get y by itself, we're going to have to divide both sides by 6. So let's go ahead and do that. So I'm going to divide this side by 6, this side by 6, and then write it as two separate fractions just like I did this one. 6 divided by 6 is 1. 1 times y is y equal negative 10 6x plus 12 6. And then simplifying, this becomes negative 10 6 is a negative 5/3, so that's negative 5/3 x. And then 12 divided by 6 is 2. So now once I do that, I now know the slope of this line, and the slope of this line is negative 5/3. So I found the slope of this line, so I see those slopes. And now when I compare those two numbers, I notice that those are negative reciprocals of each other. So you're going to say since, so notice there's the work. So since the slopes are negative reciprocals of each other, the lines are perpendicular. Okay? All right, so we had quite a few perpendiculars here. I did not mean for that to happen, but it did. But that's the process you go through. Okay, so that is it. That is the key to the worksheet on determining whether two lines are parallel, perpendicular, or neither.